Hi everyone, I wanted to walk you through a problem if you were asked to devise a synthesis, which this is something that you will be asked to do on the quiz. So when we look at how to devise a synthesis, there's a few different things we have to think about. So you would be given both the reactant and the product, and then you will be shown like this double arrow. So it can be shown in this manner, or you sometimes will see it in this manner. And what that indicates is that there's going to be more than one step that is required for this reaction to proceed from A to B. So we can look at it in a few different manners. So we can look at it in the forward direction, and we can look at it in the backwards or the retro direction. When you're doing these, you may think of a different reactant or reagents to use to go to a different step, and that is fine. It doesn't mean that what you're doing is necessarily wrong. It may just be a different approach. So let's start in the forward direction. You're going to start with your reactant, and then so again, this is kind of a trial and error process until you get more comfortable with doing these devising a synthesis. Devising a synthesis is something that you will need to know how to do in Orgo 2, so it's good to try to start thinking in this fashion. So again, forward direction, we're starting with our reactant. So something that we could do is we could form a double bond here. So again, we're trying to think, how can we get this OCH3 onto this carbon atom right here? So if we put a double bond here, the next thing that we could do is we could put a hydroxyl group on that. If we put a hydroxyl group on that, we could switch that out with a bromine, because bromine would be a good leaving group. And then what we could do is we could be left with our final product. So we could put a methoxy somehow on there. So this is, again, thinking in it from the forward direction, thinking from the starting material that you're given. If you have the retro direction, so you're thinking backwards, you're going to start with your product. I personally think retro's easier, but again, it's all in your thought process. So if we go from this, let's think, how can we basically get that OCH3 on there? So what we would need is we would need some good leaving group. It could be bromine, it could be chlorine, it could be iodide, it doesn't matter. Again, you may have different thought process for these types of reactions. Once we have bromine on there, we have to think, okay, how can we get a bromine basically in this position here? So what we would have to do is we'd have to form a double bond somehow. So in order to form a double bond, we could put a hydroxyl group on here, just because we know that we can form a double bond, right? If we have a double bond, we can use like hydroboration, or we can use oxymercuration, right? So either of those, depending on where we're going to put that hydroxyl group on, the more substituted or the least substituted. So once we have that hydroxyl, the next thing that we could do is we could have that double bond, and then we would be left with our starting material, right? So when you're looking at this one, imagine that you have a double bond here, right? And we can add that hydroxyl off of that alkene, sorry. So when we're looking at this forward direction, now we have to kind of think about all the reactants that we would need. So to get from, we'll call this A to B, what we would need is basically an E2 reaction. So in order for E2 to be favored, what we know that we have to use is we have to use a bulky base. So something like potassium tert butoxide would work. When we go from product B to C, what we know is that hydroxyl is being added to the least substituted carbon atom. So since it's being added to the least substituted carbon atom, we know that we would be using hydroboration, oxidation. So we would need that borane in our THF, and then we would need hydrogen peroxide in a base, something like sodium hydroxide. So next, when we go from C to D, we have to think, okay, we know that a hydroxyl is a bad leaving group. So since a hydroxyl is a bad leaving group, we have to think, how can we make it a good leaving group? So in order to make it a good leaving group, we need acidic conditions so that we can protonate that oxygen. So in order to have acidic conditions, and in the fact that we are adding a bromine to our Next step in D, what we could use is something like hydrobromic acid. So again, it could be hydrochloric acid. You could be adding a chlorine in this position. There's a lot of different possibilities. But when we add the hydrobromic acid, we are going to protonate this oxygen. This would make this a good leaving group. And then the bromine can come in and attack this carbon atom. In order to go from D to E, what's going to happen is, let's think, okay, we have this OCH3 here. This is on a primary carbon. Since it's on a primary carbon, we know it's going to precede SN2. If it's going to precede SN2, that means that we need a strong nucleophile. If we need a strong nucleophile, we could use something ionic like sodium methoxide. So our OCH3 would be here as our nucleophile. It's going to be a strong nucleophile. It's on a primary carbon, so we can have that backside attack. So again, I know these are really hard to visualize. Try to take it step by step. There's going to be a lot of different approaches that you can take. There will be something like this on quiz 4, which is chapter 8. And then there will definitely be questions like this on the quiz for chapters 10 and 11, which are combined. So again, be familiar with all the types of reactions first, and then try to work on these. There's a lot of different problems in your textbook too at the end of the chapter that would help prepare you to do these types of questions. If you have any questions about any of this, or if you come up with your own synthesis and you want me to look at it, just send me an email and we can either set up a meeting or we can just discuss it through email. Have a great day, everyone.